So in this video, we are going to understand how React's virtual DOM actually works. So before we dive into the technical details, let's set a bit of context. React is known for its speed and smooth user experience. And the biggest reason behind it is how it handles the UI updates. So in this presentation, we'll break down in a very simple way how React optimizes performance using virtual DOM, how updates actually happen behind the scene, and how mechanisms like diffing, reconciliation, and React Fiber make React app feel fast and responsive. So let's start from the foundation, the DOM itself. To understand why React introduced virtual DOM, we first need to understand the DOM itself. So DOM stands for Document Object Model. So whenever a browser loads a web page, it doesn't display the HTML directly. It goes through three steps known as parsing, style application, and rendering. In the parsing phase, the browser reads the HTML and builds a tree-like structure called the DOM tree. Now every element like p and div become a node in this tree. In the second step, that is style application, the CSS is then applied to this tree. The browser figures out what each node should look like, creating what we call as a render tree. And finally, the browser paints the render tree onto the screen. That is what we actually see as the UI. So in simple terms, HTML becomes a tree gets style, and the style tree is painted on the screen. So now let's understand what exact problems arises when we try to directly update the real DOM. So to understand that, here we have created an employee directory table. Now suppose if I change the status of whether Emily is employed or not from no to yes, the browser just can't update this one cell. The real DOM forces the browser to do all the three steps that we just discussed, that parse the HTML, recalculate the style, and re-render the UI. So even this small change would trigger heavy works. Now suppose if this is a larger application like Facebook or Instagram, right? Many such small changes would keep on triggering, and that would impact the performance of my application. So my application will become slow and expensive. So real DOM updates are costly, even for small changes. Now the solution to this problem is the virtual DOM. So now let's look at how virtual DOM works. First, React creates this virtual DOM whenever the app renders. That's the process. So then by definition, virtual DOM is just a lightweight copy of the real DOM. It's never shown on the screen. It's what makes it faster to update. And the purpose of doing all this is simple. React can calculate the minimal changes and update only those parts of the real DOM instead of re-rendering everything. So this is what keeps a React app smooth and efficient. So now here we see a real DOM on the left. And now React takes this real DOM and creates an exact lightweight copy of it. That's the virtual DOM that you see at the right hand side. At this point, both of them look identical. Nothing has changed yet. So this is basically before update state. The structure is same, just stored in the memory instead of the actual browser. Now to understand how this diffing process exactly works, let's take an example. Now suppose user clicks this button and it causes the h1 tag content to change from title to name. So React does something smart here. It will create this new virtual DOM and it will compare it with the previous virtual DOM. Now, this process of comparing these two virtual DOM is known as diffing. So, in the diffing step, React notices that only one node has changed, that is the H1 element, and the rest of the structure is same. So, instead of updating the entire real DOM, what React does is it only updates the single H1 element inside the real DOM. And React also makes use of something known as a batch process. So if there are multiple small changes, React will collect them and applies one optimized update to the real DOM. So this is the main reason why the React app feels smooth and fast. Now, in this diffing processes, it has certain consideration. So now let's look at that considerations as well. Now, suppose if the React element has changed, so in this case, we change from H1 to P. So what React will do is it will check that the element type has completely changed and it will fully replace that node. So here in this case, it won't do any diffing process. So any internal state inside that component, say for H1, will be thrown away and the new element is created from the scratch. And the second consideration is unique keys. So when we have, say, a list, that keys are very extremely important in that scenario. So keys helps React to identify which item stayed the same, moved, were deleted, or added. So stable unique keys help React match the nodes between the old and the new virtual DOM. So this prevents unnecessary re-renders and avoids weird UI bugs. So this also helps in the performance of my React application. And by the way, all this efficiency in React, diffing, matching, prioritizing updates, is basically powered by React Fiber, which is React's internal engine for rendering. We'll go deeper into Fiber and how it works and why it made React faster in the next video.